is, again, reflection. Makes sense to start looking at the word that is our second transformation. And like I've been saying, it's a transformation that flips a figure over a line. Okay? So imagine I had this line here and I had this ruler. Well, what does it do? Reflection means it flips it across. So notice one side you can see the writing on my ruler and the other side you cannot. So that's going to be important when we're thinking about the shapes we have in terms of like triangular or something that's not going to look the same like a rectangle when we flip it across. Other than now, we see the back side of it. So it is going to matter, but basically what you need to know is that a reflection flips it over a line. Now, it doesn't have to be a vertical line. I could do the same thing. It could be a horizontal line. I could flip it down. That's a reflection. It could be a diagonal line. That is also a reflection. So this brings me to my second vocabulary word, and that is the line of reflection. Okay, so when we look at a line of reflection, we need to think about this. Okay, it is, simply put, the line that a figure is reflected over. So as I said, the line of reflection could be a horizontal line, it could be a diagonal line, or it could be a vertical line. So if we're thinking about it in terms of a coordinate plane, it could be our y-axis, it could be our x-axis, or it could be some other line with some random slope that we do not know. Could be our line of reflection. The next one is the line of symmetry. Now, it's important that you understand what symmetry is. All right? And symmetry just means, we say things are symmetrical, meaning like they look good to the naked eye. They, I'm blanking on how to describe this, but hopefully the definition will provide some insight, and I'll keep thinking about how to define symmetry. So symmetry is a line that divides a figure into mirror images. Okay. All right. And then the last vocab word we have is a figure can be reflected over a line so that the image matches the original figure if it has reflectional symmetry. Okay, so this is the last part to your vocab word. So again, we have a reflection, which is a transformation that flips a figure over a line. Line of reflection, a line that a figure is reflected over, and then a line of symmetry, a line that divides a figure into mirror images, and then a figure can be reflected over a line so that the image matches the original figure if it has reflectional symmetry. All right, so let's pause for a moment and let's put this into an actual problem. So the first one, it says graphing a point. Now remember, we use prime to represent things when we have done some form of transformation. The last transformation we did was we did a slide, which was a translation. So we denoted our new figure by denoting it with a prime, a letter prime, A prime, B prime, C prime, so on and so forth. So I have my graph here. And so it says graph the point H at -4, 5. So remember, if I have the point -4, 5, and this is my H, all right, I need to go over negative in the X direction and then up 5 in my Y direction. So my H is going to fall right here, my original point. All right, with a reflection then, I need some line to reflect it over, whether it's a horizontal, a vertical, or a horizontal, vertical, or a diagonal. My bad. So it says this image, then graph the reflected over the y-axis. So basically, all I have to do when it's a y-axis flip is I just have to change the x value. All right, so my H prime is going to now be 4, 5. Now, why does the x change if it is a y-axis flip? Well, if we're flipping it, we're keeping it at the same level, okay? But where is it changing? It's not changing at its vertical distance. It's going to be changing at its horizontal. So I'm going to go over 4 and up 5. And this would be considered my H prime. I know I've done this correctly if I can fold them in half and the dots fall right on top of each other. All right. So this was an easy one. It was only a dot. All right. So H has 4 units again to the left and H prime has 4 units to the right. It's just the shift as to where it falls horizontally, okay, not vertically because we're flipping it over that. If I were to plot my H and I said, oh, it was an X flip, I would keep it in line with my -4. I'm not changing the value of the axis I'm flipping over. However, it would become -5. So this would be an X-axis flip. All right, hopefully that makes sense. All right, so let's continue on. So the quick check on your notes asks you to graph point D, which is at -2, 1. All right. D is at 2, -1. And they want to know what D prime would be. What's going to be D prime, okay, when it is reflected over the y-axis. So pause the video and quick do this now. Okay, so we're back. So our original point was at 2, -1. This was our D, over 2, down -1. It was a y-axis flip, so my y value is not going to change. It's going to stay on the -1. However, my y value is certainly going to change. Graph the image that is Miss B, you messed up. The negative is with the 2. So, it's always important to check your work, folks. I learn this every day. All right, so -2, 1. That puts it right here. This is our D. So D prime is a y-axis flip. So again, it's going to stay at the level 1. However, D prime is going to be at a +2 on my X value. That's what's changing. My Y value is staying the same. This is the D prime. This is what you should have gotten. All right, so let's keep going now. So graphing an entire shape. We've got our points down. Now we need to deal with shapes. All right. So shapes. Let's say I had the triangle BCD. All right. B is at -3, 1. This is my B. Okay. Then I have C, which is at -2, 5. All right. And then, excuse me, I dropped my pen. Then I have D, which is at -5, 4. And I don't know why Miss B is having so much. Okay, that's D. So this creates our triangle, and I'm just going to use a ruler to hopefully make some straight lines. Alright, so anyways, we have our points here. Alright, so this is our triangle. And it says that the image is a reflection over the x-axis, which is this line right here, so we're going to be flipping it. Before we had all y-axis flips. So this time what we need to consider is that we're keeping all of our x values the same. We're not changing, we will be changing the y values. Okay, so B is at -3, so I'm going to keep it there. So when I reflect it, I'm going to look. Okay, it's 1, 2 away from -3 this way. I'm flipping it over this way, so I need to go down 1, 2, this many. And this becomes my B prime. All right. Now my C was at -2. I'm not going to change that. It was at 5. Well, now it's going to be at -5. And this becomes my C prime. Then D is at 5, 4. Well, remember, my x value is not going to change, but my y is, and now it's going to be a -4. All right, so this is my D prime. If I connect these 2 points, you would see, all right, that if I were to flip it back up, it would fall on top of each other. The most important thing I would say is picking the one point that's closest to the axis, which is B. All right, seeing how far it is, in this case it was 1, 2 blocks away. So I just want to move it. Oops, this should be here. Man, it's B. This is why teachers need to go home before 4 o'clock at night. All right, this is where B prime would be. It's 1, 2. Alrighty, so that's how you perform it with a thing. So since B, oh my gosh. Okay, never mind. My brain is going fuzzy. Miss B made each of these little lines on hers count as a half, so that's why she had to go 2. On your graph, it's only going to be 1. All right, I wanted to make it bigger and not as condensed, so I did 2. Yours is only going to be 1 away. Okay, so it's going to be 1 below. All right, so if I were to list my coordinates, B prime would be -3, -1. C prime would be -2, -5, and then D prime would be -5, -4. All right. Now it's time to complete the second quick trick. Try and flip this yourself and see if you come up with the same answer as me. You should, pause the video, have E prime